Okay, so if you're tuned into, health, longevity, staying strong as you age, there's one piece of advice you hear constantly, just constantly.
Eat more protein.
Exactly. You need more protein. It's everywhere.
It is. And look, it's not bad advice, but it's incredibly incomplete. It sort of treats protein like this one single thing.
Like a magic bullet.
Yeah, when really protein itself is just the delivery truck. What actually matters is what's inside that truck. We need to look at the cargo.
And that is precisely what we're doing today. We are going deep on this. Our guide for this is an article from Ageless Gains by Troy Teixeira called Amino Acids and the Real Story Behind Protein.
A really insightful piece.
Totally. So our mission here is to get past just, counting grams of protein. We want you to understand the building blocks, the amino acids.
Yeah.
Because knowing about them,
Sure.
that's what really impacts recovery, strength, vitality, especially as the years tick by.
Right. So let's start right at the foundation. What exactly are amino acids? Chemically speaking, they're organic compounds. They're made of nitrogen, carbon, hydrogen, oxygen.
The basic element.
The basic elements, yeah. And they are the fundamental raw materials your body uses to build proteins. And those proteins, they do almost everything. Building muscle, repairing tissue, supporting immune function, regulating hormones, you name it.
So way beyond just building bigger muscles then. This is core infrastructure for, everything, keeping us running.
Absolutely. And the source, the article, uses this great analogy, the Lego brick analogy.
Ah, yes. I like that one.
It's perfect, isn't it? Your body doesn't really care if the protein came from some fancy branded tub or, a perfectly grilled piece of fish.
It just sees the bricks.
It just sees the bricks. It asks, are these the right shapes? Are there enough of them? That's the bottom line.
Okay, that Lego idea really clarifies things. But does it also mean, if you get a cheap protein powder that's maybe bulked out, are those just useless bricks the body can't click together?
That's exactly the kind of question it raises.
Yeah.
When we talk about what our bodies need, we're focused on 20 main amino acids, and these fall into two really crucial groups.
Okay.
First, you've got the 9 essential amino acids. Essential means, it means your body just can't make them from scratch. You absolutely have to get them from your diet. No negotiation.
Non-negotiable inputs. Got it. 9 of them. And the other 11.
Those are the non-essential ones. And that name, it sounds a bit misleading, doesn't it? Like they're optional or something.
Yeah, non-essential sounds like, don't worry about those.
Which could lead you down a bad path diet-wise.
It really could. It's a dangerous simplification. Non-essential just means your body has the machinery to make them internally. But, and this is a big but, that ability depends entirely on having enough raw materials, the right precursor molecules, and not being under constant severe stress.
Okay. So if you're training super hard or maybe chronically stressed or just not eating enough overall. Exactly. If you're pushing the limits, maybe not recovering well, maybe low on certain nutrients, that internal factory, it slows right down. It can't keep up production of those non-essentials, even though technically it could if everything was optimal.
So, okay, we need those 9 essential bricks from our food. Where do we reliably get the whole set in one go?
You look for what are called complete protein sources. These are foods that naturally contain all 9 essential amino acids and in good amounts.
And the classic examples are?
Usually animal proteins, things like eggs, meat, fish, dairy. They're often used as the benchmark because their amino acid profile is already pretty close to what humans need.
But times are changing, and lots of people are eating more plants. It's important to say, right, that some plant sources do count as complete.
Oh, absolutely. Things like soy, quinoa, hemp seed, buckwheat, those definitely qualify. They tick all the boxes for the essential 9.
Okay, good to know.
But most other plant proteins, think beans, lentils, nuts, grains, they are typically incomplete, meaning they're low or even missing one or more of those essential 9.
Right. And this is why, for anyone eating mostly plants, vegetarians, vegans, nutritional strategy becomes really key. It's less about individual foods and more about smart combinations.
Like the classic rice and beans pairing.
Exactly like rice and beans, or maybe having nuts earlier in the day and legumes later. You combine different incomplete sources over the course of the day, and together they provide that full set of essential amino acids. You build the complete set piece by piece.
Okay, makes sense. But what happens if you mess this up? Maybe you consistently don't eat enough protein overall, or you rely too much on incomplete sources without combining them properly. What's the consequence?
Well, your body essentially goes into a resource deficit. It just doesn't have enough of those essential building blocks. So it struggles to make the non-essential ones it needs for just basic daily upkeep.
And that's when progress stops.
That's the definition of stalled gains, really.
Yeah.
You might feel like you never fully recover from workouts, your energy just drags, your body can't repair tissues efficiently. If you don't supply the bricks, construction halts. Simple as that. Okay, let's shift gears a bit. Let's talk about the rock stars of the amino acid world. Branched-chain amino acids, BCAAs. They are everywhere in supplements. Why the hype? What makes them special?
Right, the BCAAs, they're actually 3 specific essential amino acids: leucine, isoleucine, and valine.
So we have to get them from food, too.
Correct. They get that branch chain name simply because of their chemical structure. If you look at it, it literally branches off kind of like a little fork. And this unique structure means they can be metabolized differently. They can actually be processed directly in your muscles, kind of bypassing the liver initially. That makes them very responsive to physical activity.
Okay, now here's where the article gets really interesting, I thought. Out of those 3 BCAAs, one stands out: leucine. It's not just present, it's an active trigger. Wow.
It's the absolute key player, yes. We need to understand this mechanism. Leucine isn't just another brick, it's the foreman blowing the whistle to start construction. It directly activates a pathway called mTOR.
mTOR. Heard of it, but break it down.
Okay, so mTOR is basically the master regulator inside your cells for growth, making new proteins, survival. It's a central command. When enough leucine shows up, and there's a specific threshold you need to hit.
Ah, a threshold.
Yes, a threshold. When you hit that, leucine effectively signals to mTOR, okay, building materials are here, start building. It triggers muscle protein synthesis, or MPS. That's the actual process of repairing and building new muscle tissue. Leucine fires the starting gun.
That makes it super clear why it gets so much attention. But let me ask the question probably on a lot of listeners' minds. If I'm already eating good quality, complete proteins like chicken, eggs, maybe some quinoa and cats, those already have leucine, right?
Yeah.
So is buying a separate BCAA powder just, well, expensive marketing mostly? Or is there a real use case?
That's the perfect critical question to ask. And the source material definitely emphasizes whole foods first. Always. But it does explain why BCAAs became popular supplements. During really long, intense exercise, think endurance athletes, or maybe during extended fasting periods, your body can start tapping into the BCAAs stored directly in your muscles for energy.
Using muscle for fuel.
Potentially, yes. So the idea is taking BCAAs before or during that kind of activity might provide readily available fuel, possibly sparing your muscle tissue from being broken down.
Okay, so a specific scenario.
A specific scenario. But, and this is crucial, if your overall diet is already solid, packed with high-quality, complete protein space throughout the day, the actual need for extra isolated BCAAs is probably much, much lower for most people. There may be a targeted tool in specific situations, not some kind of magic dust everyone needs.
Right. Got it. That actually leads perfectly into this idea of a backup fuel system. You mentioned the body might use BCAAs from muscle. Normally, our bodies prefer carbs and fats for energy.
Right.
That's the easy stuff.
That's the preferred fuel, absolutely. Readily available glucose from carbs or stored body fat.
But what happens when those run low? Say you're doing intermittent fasting for a long stretch, or maybe a really grueling multi-hour workout, or even pushing a very low-carb diet really hard. What does the body do to keep the lights on?
It switches on the emergency backup generator. The process is called gluconeogenesis. Gluconeogenesis, making new glucose.
Okay. Sounds serious.
It is, in a way. It's a survival mechanism. The body starts taking non-carbohydrate things, primarily certain amino acids, but also lactate glycerol, and converts them in the liver into glucose. It does this mainly to fuel the brain, which heavily relies on glucose and other essential functions.
Now, the article uses an analogy here that, well, it really makes you pause. It compares this process to burning your furniture to stay warm.
It's a powerful analogy, isn't it?
It really is, because it gets the point across. Yeah, you'll survive. You'll generate the energy you desperately need in that moment.
Right.
But the cost, you're literally sacrificing your own structure, your furniture, your muscle.
Exactly. And think about the implications if your goal is actually to build a stronger body, improve endurance, get leaner. If you consistently undereat protein, or just calories in general, You force your body into this state more often.
So you're working against yourself.
You risk actively reversing your progress. Your body has to break down existing muscle tissue, the very thing you're trying to build or preserve, to get those amino acids it needs for gluconeogenesis. Not only for energy, but also to keep making essential things like enzymes and hormones if dietary intake is too low.
Wow. Okay. And I suspect that deep, dragging fatigue, the brain fog, the burnout that people feel when they push a diet or training cycle way too hard, that might be linked to this kind of structural sacrifice, this energy debt.
It's very likely a major contributor. It's a critical warning sign from your body saying, hey, we're running on fumes here and we're starting to dismantle things to keep going. You're not just stalling, you're potentially going backwards by cannibalizing the very tissues you want to improve, taking Lego bricks from structures you already built.
Okay, so stepping back from all the details, what's the big takeaway here for someone listening trying to optimize things? It sounds like it's definitely not just eat more protein. It's smarter protein.
It's about being much more strategic. It's about the quality of the protein, ensuring you get those essential amino acids. It's about the timing sometimes. And critically, it's about recognizing that your body's needs and its efficiency, they change, especially over time.
Ah, okay. Let's talk about that. The article really emphasizes the implications for aging, right?
Yeah.
Particularly hitting your 40s and beyond.
Yes. This is where understanding amino acids becomes incredibly important. There's a well-documented phenomenon called anabolic resistance.
Anabolic resistance. Okay, what does that mean, practically?
Practically, it means as you get older, your muscles become less sensitive, less responsive to the signals that normally tell them to grow or repair. Signals like exercise and signals like amino acids, especially leucine.
Less sensitive.
Yeah.
So you need a bigger signal to get the same effect.
Precisely. You need a significantly higher dose of essential amino acids, particularly hitting that critical leucine threshold we talked about, just to flip that MPS switch to kickstart muscle protein synthesis compared to what a younger person might need.
Whoa, okay, that's fundamental. So does that mean the old advice like aim for 20 to 30 grams of protein per meal, that might suddenly not be enough for someone who's, say, 55 and still hitting the gym hard?
The evidence strongly suggests, yes, that might not be optimal anymore, where maybe 20 grams of good protein after a workout was plenty for a 25-year-old to maximize MPS. That same person in their mid-50s might need 30 grams, maybe even 40 grams or potentially more of high-quality leucine-rich protein in that single sitting just to overcome that resistance and get a similarly robust muscle-building response.
40 grams in one meal. That's a lot more than many people probably aim for.
It can be. It's about hitting that higher threshold needed just to get the message through loud and clear to those less sensitive muscle cells.
That completely reframes how you'd approach protein intake. It's not just about hitting a total number by the end of the day. It becomes this targeted meal-by-meal strategy, doesn't it?
Exactly. It forces you to be way more discerning about the source of your protein at each meal, ensuring it's high quality, rich in essentials, especially leucine, and making sure the dose is sufficient.
Because you're actively fighting against that natural decline in metabolic efficiency.
You got it. You're not just casually tossing bricks onto the pile. You're strategically placing the most important ones in the right amounts to make sure construction actually happens. Understanding the Lego bricks, the amino acids, is really the only way to build that effective strategy as we age.
Man, this has been incredibly illuminating. Really digging into Troy Titera's work here from Ageless Gains makes it so much clearer. So, quick recap. Protein is the truck, amino acids are the crucial cargo. We need all 9 essential ones from food. Leucine is the key trigger for muscle growth via mTOR. And letting your body resort to burning muscle for fuel, gluconeogenesis, is like burning your furniture. Costly.
Well summarized. And maybe to leave you with one final thought to chew on, building on that idea of anabolic resistance.
Okay.
Since your body gets less efficient at using amino acids with age, don't just focus on your total daily protein number. Challenge yourself to think about how you distribute those high-quality essential amino acid hits throughout the day. Are you getting enough leucine at breakfast, lunch, and dinner to repeatedly hit that MPS trigger threshold? Or are you loading most of it into one big meal? Spreading it out might be key to maximizing that anabolic signal over 24 hours, especially when fighting resistance.
That's a fantastic, actionable challenge. Thinking about distribution, not just accumulation. Great point.
Something to consider.
Definitely. Well, thank you for joining us on this deep dive. We really hope you feel better equipped now to think beyond just protein and focus on what truly matters for building and maintaining a strong, resilient body.